is our AP Stats project, and we will be finding out if juniors we know at EPHS reply faster to our text messages if we include a smiley face. My name's Chloe.
My name's Kennedy.
My name's Bella.
Okay, so for our experimental design process, what are the treatments? Our treatments are text messages with smiley faces, and the control group is the text messages without smiley faces. The response variable is the outcomes we are measuring are the number of minutes it takes for the respondent to answer, and we will monitor the number of minutes it takes for our friends to respond to our text messages throughout the process and be sure that we're recording our data. We assigned our subjects to treatments using a random number generator. So the first step of our process would be to assign our 30 friends either a smiley face or a no smiley face. We would do this by using the random number generator to select numbers from 1 through 30 to pick 5 numbers for smiley faces per text sender, which is Kennedy, Chloe, or Bella, with no repeats. So that means after a number is picked, it has to be removed from the generator. And this is after we divide the friends up into tens between text senders. The remaining numbers would be the friends that don't receive a smiley face, or in other words, become our control group. So each group has 10 people in it, 5 people with smiley faces and 5 people without smiley faces.
We chose a back-to-back stem and leaf plot to show our data. You can see that the smiley faces are skewed left, while our no smiley faces is skewed right. Our raw data is in no particular order. In minutes, with smiley faces, it's 70, 170, 120, 8, 1, 1, 1, 14, 64, 98, 28, 45, 63, 1, and 2. And with no smiley faces, also in minutes, 40, 43, 63, 6, 78, 6, 14, 116, 97, 210, 23, 26, 40, 120, and 31. Our summary statistics mean for smiley faces is 45.733, and our mean for no smiley faces is 60.867. Our median for smiley faces is 28, and our median for no smiley faces is 40.
Now we're going to move on to the pictures. So we have 2 pictures from my control group, one from Austin showing the time and how long it took to respond, and then one from Andre. So this is a graph showing how we each randomly assigned students. So first we got 30 juniors from EPHS that we know, and we randomly assigned them. So Kennedy got 5 students with no smiley face, and then 5 students with smiley face. And then Chloe got randomly assigned 5 students no smiley face, 5 students with smiley face, and the exact same with Bella. And then this is how fast the respondents reply in minutes. So then we got a graph that simulated the difference in means, and there are 25 dots, which is 25% in the selected region. And then the number of samples was 100 that we did, and the most recent result was 36.6, and the mean was 0.096, and the standard deviation was 22.381.
Okay, so like I said, the first step of our process would be to assign our 30 friends either a smiley face or no smiley face using the random number generator. And we did select 5 people for a smiley face, and then the leftover people were the control group without a smiley face per text sender. So then after that, we would send the text to our friends and monitor how quickly they would respond to the text with minutes, and with or without the smiley faces, recording our information as we go. So comparisons of at least 2 treatment groups, one of which could be a control group. So our control groups were the text without smiley faces, so that we could compare the number of minutes it took these friends to respond in comparison to the text messages sent with smiley faces. The random assignment of treatments to experimental units. The purpose of the random generator was to reduce bias within our experimental units and prove the cause and effect sequence of the experiment. With replication, we have 15 people receiving text with smiley faces and 15 people receiving text without smiley faces. And then the control of the potential confounding variables were appropriate. The control of potential confounding variable is the exact text messages each sender is sending. So it was either, are you going to the game on Friday with a smiley face, or are you going to the game on Friday without a smiley face? And then there was no blinding.
For our statistical analysis, we will numerically summarize our data by using the median and IQR because our graphs were not symmetric.
Then we got a conclusion. So our hypothesis is that we thought people would respond faster without the smiley face, but because there wasn't enough data to prove our side, we weren't successful or unsuccessful with our statement. The median of the smiley face text was 28 minutes, and the median of the no smiley face text was 40 minutes. The interquartile range for smiley face text ranged from 1 to 170 minutes, with quartile 1 being 1 minute and quartile 3 being 70 minutes. The interquartile range for text messages without using the smiley faces was 6 to 210 minutes, with quartile 1 being 6 minutes and quartile 3 being 97 minutes. So with this data, we can generalize the results to the junior friends of Chloe, Kennedy, and Bella that this experiment did not contain a random sample because we can only generalize these results to the subjects we chose, which are our friends. Lastly, we have a reflection. So one thing we may have done wrong was messaging the students on Instagram. Many students have turned off their Instagram notifications, but all of the messages were sent through that platform. As a result, some EPHS juniors didn't see the text until much later. Then, we also sent texts to students during school hours, which meant that some EPHS juniors were unable to check their phones because they were in class. For instance, students in Mr. Cannon's class had a test, making it difficult for them to see the messages. If we were to do this experiment again, we would make sure to text the students outside of school hours and make sure to collect each student's number so that we can text them all on iMessages. Thank you.